Cybersecurity technology are being engineered into the F-22 is designed to enable the stealth fighter to counter attacks from emerging future enemy threats, dogfight successfully against Russian and Chinese fifth-generation stealth fighters, and fly successfully well into the 2060s. For example, newer F-22s have a technology called synthetic aperture radar, or SAR, which uses electromagnetic signals or pings to deliver a picture or rendering of the terrain below, allow for better target identification. The synthetic aperture radar technology sends a ping to the ground and then analyzes the return signal to calculate the contours, distance and characteristics of the ground below. Synthetic aperture radar enables pilots to dynamically survey target areas and adjust to new targets in flight. Previously, F-22s would take off with predetermined target, F-22 pilots told U.S. military news. Many Air Force developers observers have credited the speed, maneuverability, weapons and stealth characteristics as advantages which make it the most advanced air-to-air fighter the world has ever seen. The operational efficacy of the emerging Chinese J-20 and J-30 stealth fighters, and the Russian fifth-generation PAK-50 are not as of yet fully known. As a fifth-generation stealth fighter, the F-22 is specifically engineered for air supremacy and air dominance missions, meaning its radar evading technology is designed to elude and destroy enemy air defenses. The aircraft is also configured to function as the world's premier air-to-air fighter, able to dogfight and readily destroy enemy aircraft. The F-22's command and control sensors and avionics help other coalition aircraft identify and destroy targets. While some of the aircraft's technologies are not publicly discussable, F-22 pilots and developers say that the F-22's active and passive sensors allow it to function as an aerial quarterback, allowing the mission to unfold. Drawing upon information from a ground command and control center or nearby surveillance plane, such as a joint surveillance and target attack radar system, the F-22 can receive information or target coordinates from nearby drones. The F-22 is known for a range of technologies, including an ability called supercruise, which enables the fighter to reach speeds of Mach 1.5 without needing to turn on its afterburners. Current fighters need to consume much more fuel to operate at supersonic speeds, F-22 pilots say. The fighter jet fires a 20mm cannon and has the ability to carry and fire all the air-to-air and air-to-ground weapons, including precision-guided ground bombs. Such joint direct attack munitions called the GBU-32 and GBU-39, pilots explained. In the air-to-air configuration, the Raptor carries 6 AIM-120 AMRAAMs and 2 AIM-9 Sidewinders, he added. Made by Lockheed Martin and Boeing, the F-22 uses 2 Pratt & Whitney F119 PW-100 turbofan engines with afterburners and 2-dimensional thrust vectoring nozzles, an Air Force statement said. It is 16 feet tall, 62 feet long and weighs 43,340 pounds. Its maximum takeoff weight is 83,500. The aircraft was first introduced in December of 2005, and each plane costs $143 million, Air Force statements say. The Air Force's stealthy F-22 Raptor fighter jet delivered some of the first strikes in the U.S.-led attacks on the Islamic State in Iraq and Syria, when aerial bombing began in 2014, service officials told U.S. military news channel. After delivering some of the first strikes in the U.S. coalition-led military action against ISIS, the F-22 began to shift its focus from an air dominance mission to one more focused on supporting attacks on the ground. Even though ISIS does not have sophisticated air defenses or fighter jets of their own to challenge the F-22, it was still helpful to attacks on ISIS.
NORAD's cutting-edge technology provides real-time updates on Santa's Yuletide journey around the world. Our constellation of defense satellites use infrared radar to keep pinpoint accuracy on the heat signature from Rudolph's nose. Ground-based radar tracking sites relay updates to our elite fighter pilots, who often escort Santa's sleigh through North American airspace. Our maritime forces in the Navy and Coast Guard make sure the seas are safe and secure beneath the flight path of the man in red. And finally, our special Santa cameras in strategic locations around the world capture images of Santa during his flight. Modern technology also allows people around the world to keep up with Santa's flight path using mobile apps, social media, and the NORAD Track Santa website. At the heart of it all, people can call or email the NORAD Track Santa Operations Center in Colorado Springs on December 24th. Volunteers are standing by to answer that all-important question.
F-22 cyber defense. Along with upgraded radar and new software-driven weapons interfaces, the F-22 is also receiving upgraded cyber defenses. The Air Force is working closely with industry partners to strengthen cybersecurity for larger service platforms such as an F-22 or F-35 fighters. We have to understand that today's weapon systems are not operating in isolation. They are operating as part of a netted enterprise. Each weapon system will interface with the broader DoD network, Alan Ballinger, Vice President of the Air Force Division at Ingility Corp., told U.S. Military News Channel. Earlier this year, Ingility was recently awarded a $31 million task order deal from the Air Force Lifecycle Management Center at Hanscom AFB, Mass. The F-22, often referred to by Air Force developers as an aerial quarterback, relies upon data link technology connecting to other aircraft and ground stations as more of the F-22's technologies and avionics, such as radar warning receivers, mission data files, navigation and target mapping systems, are computer-based. The emerging F-35 sensor fusion is entirely contingent upon modernized computer algorithms able to help gather, organize and present combat-relevant information to a pilot by synthesizing otherwise disparate data such as targeting, mapping and sensor data onto a single screen. The real focus is on the cyber vulnerability assessments across many Air Force platforms, such as command and control and battle management systems, Ballinger said. Ingility's focus is closely aligned with cybersecurity priorities recently articulated by senior Air Force leaders. In recent years, General Ellen Polakowski, commander of Air Force Material Command, has articulated 7 lines of attack that are essential to better securing networks, data and command and control systems. One of the key initiatives informing this effort is an attempt to bake in cybersecurity provisions into the earliest phases of weapons development. Part of the focus, Ballinger explained, is to examine trends in current security controls with a mind to the kinds of attacks likely to emerge in the future against IT systems, platforms and networked weapons. While increased interoperability among networks, weapons and platforms vastly expedites combat efficacy in a wide range of scenarios, Ballinger emphasized that greater connectivity can also increase vulnerability to malicious penetration and server attacks, among other problems. We are looking much earlier in the life cycle of these systems with a concern not just about their security but how they interface with other elements of the network. We want to embed cybersecurity earlier in the process, Ballinger added. Seeking to emulate threat vectors and anticipate potential methods of attack, such as how a web-based application could be exploited or the extent to which a trapdoor may interact with other elements, is an important ingredient in establishing the most effective security protocols. Also, much of this begins and ends with network IP protocol, codes which can both further enable interoperability between networks and systems while also possibly exposing networks to additional vulnerabilities. When you have an IP address that is assigned to you, you need to have the appropriate controls in place to reduce that vulnerability, Ballinger added. The need for better information security extends from larger systems down to an individual soldier or airman on a particular combat mission. Tactical air controllers use ground targeting technology is used to identify and secure targets for nearby air assets. This kind of air-ground synergy is itself reliant upon computer networking technologies, he explained. You do not want someone to manipulate data going from airmen on the ground to a shooter in the air, Ballinger said.